sulfur is the only element we can dig out of the ground in large quantities in a pure form and burn in an exothermic reaction. I'm going to demonstrate how sulfur can be combined with oxygen, essentially burned, to produce heat energy in an exothermic reaction. To do that, I've taken molten sulfur and dipped a cloth wick in it to make what's basically a sulfur candle. Now I'm going to light this, and just like a wax candle, it's going to burn, except the sulfur is the fuel rather than the wax. There. Now you can see that that's burning. There's a flame and you can see smoke coming off of there. Now that's sulfur, and you can see that it's melting from the heat. That's sulfur burning in an exothermic reaction. Now, I'm going to put this out and then explain why we can't burn it in the air like this in a second. Now in that reaction that I just showed you, we have sulfur combining with oxygen to form sulfur dioxide and heat. Now the problem with that, as I said before, is sulfur dioxide is a very toxic gas, and so we can't generate energy as a practical matter by burning sulfur dioxide in the air. But there's another way to burn sulfur and get the energy out, and that's with a fuel cell.
Go.
Alright, here we have a basic fuel cell diagram. And you'll notice that instead of heat in the form of the match to get the reaction going, what we have is an electrolyte solution, sodium hydroxide, or in this diagram, potassium hydroxide. Now this is a hydrogen fuel cell, and there are two electrodes suspended in the the potassium hydroxide, here and here. Now at the oxygen electrode, we pump oxygen into solution. It goes into solution and forms the OH ions, which travel over to the second electrode where the hydrogen gas has gone into solution. Now the OH ions combine with the hydrogen in solution to form water, and instead of giving off heat, which we had in the reaction where we burn it in the atmosphere, it gives off an electron. Now that electron travels up through the wire conductor that connects the two electrodes and goes back in at the oxygen electrode to drive another reaction. And so that electron keeps circulating. And it's the force of the reaction that gives the electron the force to travel through the circuit, and basically is the electricity that we see generated, and which we use to operate light bulbs, cars, etc. Now we can do the same thing with sulfur. So instead of having hydrogen at this electrode, we substitute sulfur, and we pump oxygen in the same way as we do with a hydrogen fuel cell. And so instead of forming H2O, we form sulfur dioxide, which goes into solution and then reacts with the sodium hydroxide to form water and a salt. And so, as with a hydrogen fuel cell, we have zero gas emission in a sulfur fuel cell. Now what I've got here is a solution of sodium hydroxide. That's the electrolyte that this fuel cell runs in. Now over here where my red lead goes in, I have got a stainless steel electrode. Now this electrolyte has oxygen dissolved in it, and so it will run for a while just on the oxygen dissolved in the electrolyte. And the stainless steel electrode takes and puts that oxygen into solution to form OH ions, which then travel over to the sulfur graphite electrode and react with the sulfur to form sulfur dioxide and give off an electron, which then produces electricity, which will then run through the circuit, will register on this voltmeter, and then go back into my oxygen electrode to do another circuit. That's essentially how this fuel cell operates. Now I'm going to touch the black negative lead to the aluminum, and you will see an amperage register on my voltmeter. Now that's showing about 19, 16, 13 milliamps. It varies depending on the amount of resistance coming through here in the reaction. Now sometimes it goes up, when it's reading high like that, it's going beyond the limit of 20 milliamps. Now I'm going to switch this to show you the voltage that I'm getting from this. Okay, I'm switching it to DC voltage, and we're getting about a half a volt out of this, which is the force of the reaction. Now once again, it varies because I don't have real strong oxygen going in there, and sometimes the contact varies, but we're pretty consistent at about half a volt on this. And that's basically how we're using sulfur to combine it with oxygen to produce electricity without any harmful emissions.